The last thing we are going to talk about are polyatomic ions, and that is a group of covalently bonded atoms with a charge, and they always stay together. So when you saw that video about ionics dissolving, this is true. This is an ion, and anything it's attached to will dissolve, but as a group, the carbon and oxygen stay together as a whole. Okay? So when we do the Lewis dot for ions, they have to be in brackets and they need their charge on the outside. We need to add or subtract electrons based on the charge. So carbonate, which is CO3 with the 2 minus, has C, 3 oxygen, 2 minus. How did I become 2 minus? Well, I added 2 electrons. Okay, if it was a positive, you'd be subtracting those electrons. So we have a total of 24 valence electrons, and here I have my 24 valence electrons. I didn't have enough to make an octet around that carbon, so I had to share that pair, and I have it in brackets, and I have my 2 minus on the outside of those brackets because that's how we do an ion. So something we need to talk about that confuses a lot of people is resonance. Resonance is when 2 or more Lewis structures can be written. Okay, in bond order, this is the bond length, and the bond length is actually the average of all of those resonance structures, because the one that you draw doesn't exist in nature. It's an average of all of them that you can draw. So here's our carbonate again with 24 valence electrons, and I chose to put my double bond over here. So why did I pick there instead of there or there? Well, when I was in high school, I'm like, what difference does it make? You can rotate this whole thing around. Well, it is true that we could rotate it, but if I could write multiple, so I pick my double bond on the right side instead of the left, I pick my double bond going up. We need all 3 to know that this is an average bond length. So I have single bond, double bond, single bond, double bond, single bond, double bond. And when they test this using analytical equipment, they don't find 1 double bond and 2 singles. Okay, they find that all the bond lengths are actually the same, and it is a bond length of 1.33, right? Because I have 1 plus 1 plus 2, which is 4, divided by 3. That's my average. That gives me 1.33. Okay? And bond lengths are interesting because if we have a single bond, they're longer than a double bond, right? It's like we have a stronger bond, so it pulls that oxygen in closer. So they would have expected to find one of these bonds being shorter, but that's not the case. That's why you have to draw all 3 resonance. They have to be in brackets with the charges on the outside, and you need these arrows. These double-headed arrows show resonance. So in chemistry, the arrows are very specific. If I'm doing a reaction, my yield is just a 1-headed arrow going to the right. Okay, but we need a double-headed arrow for our resonance, and again, our bond length is 1.33. Okay. And then, oops. Okay, so that's our resonance arrow. And we will practice some of those next.